All right. Any questions off your homework? Start with. Everybody's good with all of them, even the last two? Okay. A lot of times on the homework, you'll get a little bit of a different take on one or two problems than what we talked about, which is kind of a different look on the last two there. And working with those function values. Also, I've got your first test date back on the board in the back, 31st. It's also listed on Canvas, if you forget, but that's actually the first full day of class, that Monday. That's just when it fell. I certainly don't want to do a test on a half day. Probably could have done it on Thursday or Friday, but didn't want to do it on a half day. So just did some extra review stuff and then into that full day. That ended up there. Okay. All right. So we're going to look at some limits today. And to save time because of the half days, I went ahead and completed these charts. Now we'll come back to these charts over the next few days, a couple different times. Look back at them. So that's one of the reasons I wanted you to have the chart down. Now, when you were finding a function value on the homework, so just some generic one here. You know, if we found f of 2, we'd say f of 2 is 9, and that was the 0.29. Everybody agree with that?
Yeah.
So what we're saying is that function, in this case it's a linear one, exists at the 0.29. There's nothing wrong with it. Okay. Does that make sense to everyone? Okay. It's going to go through that point. When we go to a limit, the limit is what the function approaches from both sides. What it's approaching from both sides. The point may not actually be there. Okay, so to give you some graphical representations. If I had something like this, if I'm moving in from both sides towards that hole, that limit exists. It's what you're approaching. Okay? So let's say on a graph, this was the point, make something up here, let's say it's the 0.58. Okay? So that would mean as x is approaching 5 from both sides, I'm approaching a y value of 8. Does that make sense? The point doesn't exist. There is no 0.58. I'm approaching a value of 8. I never actually get there. Right, so that's the point of a couple of charts here. If this was, forget the limit here, if this was just my function. So you've seen a rational function before. Nothing new there. Okay? When you look at this, the domain of that would be x can't be negative 2, right? Okay, pretty simple there. Right? Now we're going to investigate the limit as x approaches negative 2. So in other words, there is no value at negative 2. That was the domain restriction. So I can't just substitute a negative 2 in and get a value out. Does that make sense to everyone? Okay. But I can see if the graph is approaching from both sides some same value. So I work the chart. So in this case, negative 2 would be right here. So I just surrounded negative 2 with decimals really, really close to negative 2. Because even though I can't substitute negative 2, I can substitute negative 1.999 in for x. I can substitute negative 2.001 in for x. I can substitute anything close to negative 2. I just can't substitute negative 2. So there's why I came out with these numbers. I was just trying to get close to this guy. And when I used the calculator and substituted these values in, these were the y values I got from it. All right, so you can go on your calculator and check for yourself, but that's just what I ended up with when I substituted the values in. Okay? And what we can see is from both sides, so I'm on the left side of negative 2, right side of negative 2, and as I'm getting closer, the y values are getting closer to 12. Now it won't ever reach a 12, because it doesn't exist there, it's a hole. But you can see them closing in on 12 from both sides. So we would say the limit is 12. Everybody okay with that? So this graph, negative 2, 12, I'm not exactly, without getting my calculator out, exactly positive graph is, but we're something like this. And we'll look at the graph later on. But it's something like that where that point is negative 2, 12. So from both sides, I'm approaching that y value of 12. Okay there? Okay, I go to the next one. Again, here's my function. Domain is x can't be 0. That should look pretty familiar. Okay. Now we get this statement in front. So this is reading the limit as x approaches 0. Well, I can't substitute 0, but I can investigate what's going on around 0. So I look to the immediate left and immediate right of 0. So again, just made a chart, decimals close, a little further away, but I'm still staying close to 0 on both sides. And when I put the values in and go calculate what the y value would be if I substitute 0.001 or negative 0.01n, I get these y values. Now, are these two y values coming together towards the same number? Oh, they're getting further apart, right? So we'd say the limit doesn't exist. It's not approaching the same thing from both sides. A picture of this graph looks something like this. And again, if we had the full class period, we'll take time and graph on our calculators, get used to some things, but we got plenty of time for that. But that's kind of what the graph looks like. So if you see that x value of 0 right here, are we approaching the same thing from the left and right? No way. They're going opposite directions. They're not coming together like this guy was. That's why we'd say it does not exist.
Isn't there like a thing where it's like the limit from the negative to positive side is this, and the limit from the positive to the negative side is this? Is that a thing that you can do?
That's a one-sided limit. We'll get to those later. So yes, we do have a one-sided limit where we can look at just one part of it. Okay? But if I see just a number there, then I've got to look at both sides. I'm examining from both sides. Okay? Charts are kind of a pain to do. Right? They're pretty simple. I mean, you can create one and you got a calculator. You can start substituting values, and they're just kind of a pain to kind of lay out and get all the values. It takes a little time. Right? But they tell you a lot. You can see what's going on here coming together versus going apart. All right, so usually charts can help you visualize what's going on a little bit better, something like that. Here's some graphs. Let's make some rough sketches here. All right, so there's some random piecewise graph. Okay. And let's say that this x value is 3. We'll say that's 4. We'll say that's 7. Just kind of get some coordinates on there, okay? Now here's what you did yesterday or for your homework. What is f of 3? Would f of 3 be the 4 or the 7?
7.
Why? Okay, it's included. It's closed, right? Okay. Everybody agree with that? Okay, now the limit as x, I'm going to call this f of x. As x approaches 3 of f of x does not exist. So the point existed, this time the limit didn't. Because when I'm looking at 3, I've got to think of it from both sides. Did I approach the same thing from both sides? And I did not. All right, so again, we'll see some one-sided limits later, but right now we're looking at both sides. I did not come together towards the same thing. Does that make sense to everyone? Let's get a different sketch here. Call that 3. Call that 4. Call that 7 again. This would still be what we call one of those piecewise functions, because you do have two parts to it. You've got the curve, and then you've got the singular point. That point is still that function value. So in this case, if I said, well, what's f of 3? Still be 7. Because that's what's closed in. Does everyone agree with that? Okay. So let's go the limit as x approaches 3, and I wrote f, that's why I call this one g. So g of x. Okay. Would the limit be does not exist?
No.
Would it be 7?
No.
Would it be 4? Yeah. So I'm looking at 3, and I'm looking from left and right along this curve. And as I approach 3, what y value am I at? I'm at a y value of 4. Is there an actual point there? No, there's not. There's a hole. Okay, the function value would be 7, but the limit is what you're approaching coming in from both sides. That makes sense to everyone? Okay. So two different things you're looking for. You're used to looking at a graph and saying, hey, what is f of 5? Well, let me find 5 on the x. What's the y value? Okay. Now you're looking at what am I approaching from left to right of 5 as I'm getting closer to it. This is kind of a different take. Let's see. We'll call that one h. A couple different values there. What do you think h of negative 3 is? Doesn't exist. You can say doesn't exist, or it's not defined, or anything like that. It's not there, right? There's no point there. Okay? How about the limit as x approaches negative 3 of h of x? Does that exist?
Yes.
Yeah, that would be a 1, right? So we're coming together at negative 3, and what y value are we at? We're at 1. That's a different idea. All right, h of negative 3 did not exist. What about h of 2? Does that exist?
Yes.
Yeah, you have a point sitting there, right? And that h of 2 value is 4. Limit as x approaches 2 of h of x. Is that 4 in this case? Everybody agree with that? You're coming together and you're at 4. So you have a case where the limit and the function value are the same thing. And you have a case where the limit and the function value are not the same thing. Depends on what we're looking for. What you're used to is being able to just take a value, substitute it in, get a value out. And that's what you did for homework. Or you look at a graph. Hey, we'll put my x value in. Where am I at on the graph, that y value? Okay. Now we're taking it one step further and saying, hey, you know what? Sometimes that value is there. Now we're going to investigate a limit, so we look at both sides. Doesn't exist. Doesn't come together. The limit can exist and be different from the value because it's what you're approaching on the graph versus the actual value. Or it could even be the same. So any of those functions that you looked at on your homework, I just asked you to find function values, they were continuous. You got to the piecewise part, and they may or may not have been continuous at that point, but I only asked you for one part of it. Okay, so a piecewise function could come up this way, and then all of a sudden this guy come in and connect. It could be split, could connect. Okay? But you were looking at continuous parts is what I was getting at. Now you're looking at some that aren't, okay, for that piece. Okay, your homework is out of section 1.2, 1, 5, 15 through 23. Now listen, on your homework, okay, anytime you see a span of numbers in here, such as 15 through 23, anytime you see that, unless I specifically write it down or tell you otherwise, it's always odds. I'm just too lazy to write odd every time. Okay. So it's 15 through 23 odd. So 15, 17, 19, 21, 23. Okay. Reason odds, answers are in the back of your book. You can check so you know what you need to ask about. Okay. Homework, when I check, I come around and do just like I did today. You check it off. I don't go back and check it again, but I would at least suggest you keep it through the first test so you can review, or maybe the term in case I make a mistake on your grade. Because if I make a mistake on your grade and I need to see it, you're going to have to show it to me again. Okay. So I don't care if you do your homework, separate sheets of paper, keep it in the notebook, whatever, because I'm not going to collect it. I just walk around and check it. Do what works best for you to keep everything together. Okay.